Hey guys, welcome back to Thriver Ashish, and this is video number 4 in System Design Primer series. We have already covered uh, 3 videos earlier in which I have already taught you system design basics, introduction, and roadmap. The second video was distributed systems. The third was of what microservices are, and this is the fourth video in which as you can see that we'll be studying gap theorem, and along with the gap theorem there is one more theorem which is called PACELC theorem. I don't know if there is an exact word to pronounce that, but this theorem, if you have not heard, like this was the extension of gap theorem basically. So these both theorems will be covering since we are working on like a system design of distributed systems. So gap theorem is really important, and why it is important you will get to know. And what is this extension, this also I'll cover in this particular video. So I'll say that watch the whole video for clear concepts which I'm telling. So let's start. What is gap theorem? I mean, what does it stands for? So C stands for consistency, and A, you already have guessed, availability, and P stands for partition tolerance. Okay, so what all these terminologies are we'll be covering further. Stay tuned. First let's see that what this theorem says, like what is the definition of this theorem. So theoretically, if we speak, as you can see on the screen, that gap theorem states that distributed data stores. Okay, so here you know what distributed systems are, and data stores also. If you don't know that, you should google it. I am not going to make a video onto this. So distributed data stores can provide at most two properties. At most, in Hindi if we'll say that, ज़्यादा से ज़्यादा दो properties out of 3. So it states that distributed data stores can provide at most two, ज़्यादा से ज़्यादा दो properties out of these 3. What all these 3 are? Consistency, partition tolerance, and availability. So in a system, gap theorem says that only as in at most 2 things can exist. Okay, so let's find it out that how and what. So remember, here you have to remember that the partition thing is, partition here refers to network partition actually. Whatever you are doing, let's suppose you have 2 database servers and you have partitioned them, but they are connected over a network communication. So I'll try to explain what it is. Like, let's suppose there are 2 databases, 2 database servers. One is this db1 and the other one is db2. Okay, so what is happening, let's suppose this is the one main db for now. Why? Because let's not say main, because not might be correct terminology here, but let's suppose that whatever is written, let's suppose I've written Ashish over here, so it will be replicated to other database server also, like Ashish, then DSA, then system design. Okay, so like this is kind of, you can say that this is a replica of, by the way, this is not a kind of backup, but this is a replica. Okay, and there's a difference between backup and replication. So I think you should be reading that as well, and I might cover in it in further videos as well. So here you see that these are the 2 databases, database 1, database 2, and this is being replicated, whatever is being written to database 1. So let's suppose and they are connected over a network. Some network call will happen which will replicate. Okay, so understand from here very I mean, hear it very consciously, because don't skip and don't fast forward. So if you let's suppose send a read request to this database server from client. You can assume whatever client is there, like there will be no client who directly accesses the database, but for now you think that the client might be any service, any microservice or whatever. So you assume that there is a client which sends a read request. It will say, it will give you the response. Let's suppose want to read any data like Ashish, it will read and the response will come. Okay, similarly here also, if you let's suppose there are other client, there is another client which makes a request here and it reads the response. Okay, and the database returns the response. So let's suppose you have you are an Instagram celebrity, and your post is being viewed by many people. Okay, so obviously one database server cannot take that much load, so you have to replicate that to other database servers. And let's suppose you have 40-50 million of followers, and at that same time, let's suppose only 1 million or 5 million people are accessing that, and it will not be possible for one database server to do that, right? So that that photograph will be with this also, what do we say here, and let's suppose xyz लिख देता हूँ, and here also that will be like here as well. Okay, by the way, I'm not suggesting that to keep photographs. This is a good thing. I will explain all those things once we'll read that. Just assume. And here also it is that. So some people will access from here, some will access from here, some will access from other database. I hope you are understanding that. So let's undo that. And what will happen here is so once I explained that why we need it. So what will happen, like this will also do a read request, it will respond. What will happen, let's suppose okay, let's suppose that celebrity itself comes and posts some picture or writes something like if it is a Twitter, let's suppose, so it will obviously write also, post something. So if it gives a write response here, okay, so once the write request goes into this, right, that has to be replicated to this database also, because next time if many people are accessing from different database servers, they need to have that particular data onto other servers as well, replicated servers, right? Now assume that, so this is called a partition tolerance. Like you have partitioned your database servers, data stores, and over the network it is tolerant enough that all the data is being replicated, and some person is reading it from other servers, some person is reading from the server where the writing is happen first, in the first go. Let's suppose if this communication over a networks breaks, okay, this gets broken. So what will happen, whatever write call will go onto this first database, it is not possible to write it on this particular system, right? So now if you're allowing this write instead of this failure, instead of this network failure, that means, what does it mean? The person who is accessing the data from here will not be able to access the data which is written just a minute ago or something like that, like after failure. What does it indicate? That your data is not consistent in between both the two, right? I hope you're getting it. I'm trying to simplify it. So if let's suppose here you wrote something like anything like CAP theorem, and there is a network failure. So obviously here it will not be written cap, right? And if somebody wants to access that, they will not get this cap theorem. So there is a data inconsistency in your system, but your data is, but your system is available for them, right? Like for, oh, sorry, for them, like you have written here, it has taken your post request and it is highly available, but it is not consistent. Okay, I hope you are getting this point. This is very important. So here now you can relate that what cap theorem says, that why it says that at most two things. So in a distributed system you have to have partition tolerance, right? You have to do the partition of your data stores. So one, this P is always gonna there. Okay, remember this. Now you have to choose between C and A, that is consistency and availability, that I explained it just a minute back, that in case of data failure, if you are choosing that your system should be highly available, like it is writing even after this request network failure, it will not be consistent, right? It will not give the same copy onto this, and the clients accessing data from this will not get that. And if you are saying that your system should be highly consistent, that whatever data present here should be there, and if there is a network failure and you are trying to write and you know that it can't replicate to all the data stores, what does it mean? It cannot be highly available, because if you write here, data will not reach here, it will, you know, arise inconsistency. So here you have to block, if this network failure happened, so you have to block this write request and you have to send error that man, I'm not able to serve this request, and your data is, your system is unavailable because you chose consistency over availability. So that trade off you have to make when you have to design a system. So I will give you one example, like Instagram I feel is a highly available system, because let's suppose I uploaded one photo and somehow their network failure or something happened, and few data stores don't have that photo of mine, but it doesn't make my friends really you know, bother. Like if they are not able to see my one photo for some minutes or some 5-10 minutes, it won't affect. But there, but the system should not be, you know, unavailable. Like I am able to post, few of my friends, those who are seeing from that particular data store where the picture is already being written, they can see, but ho sakta hai ki there might be some people who are not able to see at that particular time. So the data might not be consistent across, but the system is highly available. But on the other hand, if you'll see the bank applications, and let's suppose your father and you are a student and your father deposited some 10,000 money in your account, okay, and some network failure happened, he deposit over online or something, net banking or through that, and you are not able to see here, like the data is inconsistent. So it's like it will not be a very good user experience, right? So that's why I feel that banking applications should be like highly consistent, and that might be the reason, I don't know whether it's exactly same or not, that might be the reason that sometimes I used to get the messages from my bank that servers are under maintenance, and from 2:30 a.m. to 3:30 a.m. The services, internet banking and all will not work, plan accordingly. So they are not really highly available, but they are very consistent. So that trade-off you have to make here. So I hope you understood this. So I'll explain, this is all theory here, that so the two data stores db1 db2 have to communicate with each other over a network. They must be partition tolerant. So p jo hai na, that p so you have to take. So now the choice is between C and A. So either your system will be CP, consistent and partition tolerant, or AP, available or partition tolerant. तो यहाँ पे आपको बस ये चीज़ें याद रखनी है. This you have to. So even if your communication breaks in case of network failure, they must continue to function correctly, and correctly as in whatever you chose. So now the choice has to be made between consistency or availability, that every read request receive the most recent value of error if you are saying value, or an error if you are choosing consistency, right? And if you're choosing availability, then every request gets a valid response and no error. क्योंकि because highly available system cannot have error कि bro, I cannot serve your request, and highly consistent might have error, because if there is a network failure, you can't say that okay, this is the request I can serve, or this is the right request I can take, something like that. Or you can even take right request, but still I don't think so that you will be showing it to user, because I don't know whether you might want to queue it somewhere and then replicate when your network connection is okay, or something like that, or you need to divert the traffic to other servers which are not in the failure state. That's completely up to the design and the logic which you have written. So if you choose availability, then in case of partition failure, it won't be able to replicate the data to other stores nodes, and the data might be inconsistent, which I explained. Like the example which I gave, Instagram is a highly available system, and when network failure resolves, then it will replicate the data. Obviously, like you have written on few servers there is a data, few servers it's not present, but whenever that is resolved, it will replicate the data. But if you chose consistency, then in case of network failure, you must block the right request and send the response that system is down and not available. You cannot take that request. Yes, okay. You have to send that this is not completed now, because you have to tell user that this is not possible, dude, and we can't serve. Our system is consistent but not available. Here, I mean, we chose this gap theorem. Banking systems. So in nutshell, this is the summary or SAR जिसको हिंदी में बोलते हैं. You have to make choice in between consistency and availability while designing your system. So either your system will be CP or CA, बस इतना ही करना है. So this is a cap theorem. Now I hope you understood it, and if you really like the explanation, कर दो यार, जो भी hit like अच्छा लगेगा, दिल से बुरा नहीं लगेगा. So okay, now come to this extension of gap theorem. When some criticism happened over gap theorem, whatever कोई भी मतलब whenever there is something, some theorem, some proof or something, the criticism happens, some extensions come. So I think this theorem is an extension of that. So यहाँ पे if you can see this PAC, okay, this is same cap. इसको उल्टा कर दो आप, just reverse, like this is cap, okay, and here this will be same partition, availability, consistency. So if there is a partition, this theorem says, extension of cap theorem says, if there is a partition, yes, then it's available or consistent. You have to choose. Else, E for else, this E stands for else. If there is no partition, मतलब अगर partition, if there is a partition, consistency or availability, if there is no partition, then you have to choose between latency and consistency. Latency is nothing but a delay before the transfer of data begins, okay. So that's the only theorem says. It's an extension that if there is no partition, you have to still choose between latency and consistency. Like either your data can be consistent but with a lower latency, matlab higher latency, sorry, and either your data either your system is having lower latency, but that consistency will take a hit here. So so here one example is there, like DynamoDB, Cassandra, React, Cosmos DB. These are all PA systems. Matlab what PA systems mean? If there is partition, okay, then they will go for availability. consistency will take hit. So they are PA systems if partition is there. If I mean partition is there, like if they are in distributed kind of environment. If they are normal system, there is no partition, they will be EL systems. EL means else, L means latency. So in if partition occurs, they give consistency, they give up consistency for availability. And under normal situation, that is the else condition, if there is no partition, they give up consistency for lower latency, they want less delay. So yeah, that's it. And if you really want to follow me on Insta, Twitter, YouTube, Thriver Ashish is the handle, and all my educational content is on that. So yes, happy learning, and let's see that what we'll study in design video 5 that will be coming soon. Thank you.